All right, let's talk about simplifying square roots. We're going to break it all down, and by the end of this, I promise you'll have a super clear blueprint you can use every single time you see one of these problems.
Okay, let's kick things off with a little puzzle. Imagine you've got a square garden, and its area is 25 square feet. What's the length of one side? Easy, right? It's 5, because the square root of 25 is 5. But what if the garden's area is 8 square feet? Well, the side would be the square root of 8, and that's not a nice, clean whole number. This is exactly why we need a special technique.
So here's our game plan. We're going to cover what simplify actually means, then we'll go on a perfect square hunt. After that, we'll do a quick example with the square root of 18, and then a slightly trickier one with 72 to show you a smarter way to work. We'll also look at a common mistake so you can avoid it, and then you'll get to try one out for yourself.
All right, first things first. What does simplify even mean? When your teacher asks you to simplify a square root, what are they really asking you to do? Let's get into it. Okay, this is super important. Simplifying does not mean grabbing a calculator and getting some long, messy decimal. No way. It's more like tidying up the number that's stuck under that root symbol. The whole point is to find any perfect squares that are kind of hiding in there as factors, pull them out, and make the whole thing look as clean and exact as possible. Now, for what is honestly the most important part of this whole thing, getting our tools ready. It's time to go on a perfect square hunt. So here's the strategy. This is the real core of it. First, you've got to know your perfect squares, right? 4, 9, 16, 25, 36, and on and on. Think of these numbers as your best friends for these kinds of problems. Your mission is to find which one of these divides evenly into the number you're working with. And here's the pro tip, the secret sauce to saving a ton of time. Always, always look for the largest perfect square factor you can find. It'll make your life so much easier.
Okay, enough talk. Let's actually see this blueprint in action. We'll start with a quick example, the square root of 18.
So here we go. We're looking at the square root of 18.
Okay, time for our perfect square hunt. Let's see. Does 4 go into 18? Nope. How about 9? Yes, 9 goes in perfectly. So we can rewrite 18 as 9 times 2. Now, there's a handy math rule that lets us split this up into 2 separate roots. So the square root of 9 times 2 becomes the square root of 9 times the square root of 2. And this is the magic step. What's the square root of 9? It's just 3. And the square root of 2? Well, we can't simplify that any further, so it just hangs out. So our final, beautiful, simplified answer is 3 times the square root of 2. See? Not so bad. That was a good warm-up. Now, let's kick it up a notch with a bigger number, the square root of 72. This one is really going to show us why picking the right factor makes all the difference. In our source material, there's this student, Fernando, who felt like there just had to be a faster way to do this. He was looking for a shortcut, and guess what? He was totally right. So let's think like Fernando and find the most efficient way. Now, this is really cool. Look at this. Both paths get you to the right answer, 6 root 2. But check out the journey. On the left, maybe you spot 9 as a factor, that's fine, but then you're left with a square root of 8, and you realize, wait a minute, 8 has a perfect square inside it, 4, so you have to do the whole process again. But look at the path on the right. If you take a second to find the biggest perfect square factor, which is 36, you do it in one single clean step. Boom, done. Same answer, way less work. Okay, let's talk about a super common mistake. It's a classic trap, really. But once you see it, I promise you'll never fall for it again. So a really common mistake is just breaking the number into any 2 factors that come to mind. Like for 72, you might think, oh, 6 times 12, that works. And yeah, 6 times 12 is 72. But here's the problem. Is 6 a perfect square? Nope. Is 12? Nope. So you're totally stuck. It's a dead end. You have to backtrack and start all over. So remember the golden rule. One of your factors has to be one of those magic perfect squares. All right, so you've seen the whole process, you've seen the smart way to do it, and you've seen the trap to avoid. Now it's your turn. Time for you to take the wheel. Go ahead and pause the explainer right here. Grab a piece of paper and give this one a shot yourself. Simplify the square root of 50. Use the steps we just went over. Don't worry, I'll be right here when you're ready to check your answer. Okay, you back? Awesome. Let's walk through it and see how you did. So, we're starting with the square root of 50. First step is always the perfect square hunt. Let's run through our list. Does 4 go into 50? Nah. 9? Nope. 16? Not even close. How about 25?
Yes, perfect. 50 is just 25 times 2.
So next up, we use that rule to split them apart. That gives us the square root of 25 times the square root of 2. And now for the final step. The square root of 25 is just 5. The square root of 2, well, that's as simple as it's going to get. So we put it all together and we get 5 root 2. So how'd you do? Did you get it?
So you might be thinking, okay, but why does any of this actually matter? Well, in our source material, there's this character, Clara, who's tiling her bathroom. She needs to find a square tile with a side that's between 5 and 8 inches. The problem is, the tiles she's looking at are sold by their area, like 45 or 75 square inches. By simplifying the square roots of those areas, she can figure out the exact side length of each tile and know for sure which one will fit her project perfectly.
And that really leaves us with a final thought. Simplifying radicals isn't just some random math procedure. It's really about learning to see a cleaner, simpler structure that's hidden inside something that looks kind of messy and complicated at first. So it makes you wonder, right? What else is out there all around you that might have its own hidden, simplified blueprint just waiting for you to find it? Thanks for joining me for this one.